Good afternoon, good afternoon. Okay then, good afternoon. Okay. So I was discussing, I think, pressure of a gas. Good afternoon. GA you say, so I thought you are saying the gamma apparent because yesterday somebody asked her what is a GA. Okay. Okay. So I was discussing, your syllabus is up to the expansion of gas. This kinetic theory I am teaching extra because maybe next week the more syllabus you will get. Okay. So I think this formula you have written, I have discussed up to this. This is okay. This is, I think up to this I have discussed. Okay. Okay. So P was the what? Pressure of a gas is average velocity of gas molecule 0 up to this. Miss some problem we have. Okay. Density relation also given. Okay. So density relation means P is equal to 1/3 into rho into VRMS square. That we have written. Okay. So last year, like they asked this question, pressure matrix match, all these questions they have given from the kinetic theory. Pressure they have given ideal gas and they have given 1/3 Mn upon V into VRMS square. Okay. There is a different way we can write this pressure. One is this formula, one is this formula. Maybe sometimes what we take, what is this quantity? N is the number of molecule, V is the volume. So number of molecule per unit volume. So generally we write by small n. So small n we can say N by V. That is the number of molecules per unit volume. Okay. Then we can write P is equal to 1/3 M into N into VRMS square. So they will give what which quantity what they, it represent, like small n number of molecule per unit volume. Then you can write the formula in the place of N by V. Directly you can put the N. Okay. Everybody got? And I have discussed, I think, 1 or 2 questions on this also. Okay. Okay. Now next is the average translation kinetic energy and pressure relation. Okay, so we have to find the relation between question. I will discuss combined because first we have to complete some concept. Okay, so like directly formula based 3 formula I said, and they will say like mass of the molecule is half, number of molecule double, velocity double. So directly like question we can say. Otherwise after that VRMS when we'll discuss, then we will get the questions. Okay, Gagandeep. 2-3 question I discuss, I think. So wait, I will discuss. Okay. Okay. So average translation kinetic energy of 2-3 question yesterday day before yesterday I discussed. When mass of the molecule is halved, velocity double, what is the effect on the pressure of a gas? This question I discussed. Okay. So average translation kinetic energy of the gas and the pressure relation we have to find. So we have written what? P is equal to 1/3 M into N by V into VRMS square. I think everybody has the idea about the translation kinetic energy. What is the meaning of translation or linear kinetic energy? Because like gas molecule, so suppose this is a oxygen molecule, one oxygen atom here, oxygen atom here. So if it is a moving in a gas, moving in a container, so it can move like this maybe by rotation as well as translation. So due to the linear motion, it will have kinetic energy, that is called the translation kinetic energy. Due to rotation, it will have the rotational kinetic energy, that we have learned the formula maybe last year, half I omega square. That I will discuss later. Everybody know or not? Like motion, we can say translation motion, rotational motion. These basics maybe Akhilesh sir said. Okay, so here I am talking about the translation kinetic energy. That formula is the half mv square. Translation kinetic energy is the half mv square. Okay. So here pressure of the gas 1/3 mn upon v into v RMS square. This mn combined is what? M is the mass of one molecule and n is the total number of molecule. So mn is the mass of gas. Okay. So this I can say P is equal to 1/3 mass of gas, m suffix g I am using. Okay. mg upon v into v RMS square. Okay. Mass of gas into RMS velocity. Kinetic energy is what? Half mv square. So I need half. So what we will do? Just multiply with 2, divide with 2. Okay. Now 1/2 m into v square. That I can say the linear kinetic energy. Then P, what you will get? P is equal to 2/3 into linear kinetic energy upon volume. Okay. Or if suppose I am writing the linear kinetic energy with E, then you will get the relation P is equal to 2/3 E by V. Okay, this relation directly you have to remember. P is equal to 2/3 E by V, and the symbol also you have to know. Okay. If they are saying what is the relation between the linear kinetic energy and the pressure, so we can say P is equal to 2/3 E by V, where V is the volume. Okay. And it is a, remember that it is a linear kinetic energy. In the NCERT by the star mark they have written this. Okay. Internal energy means of the gas means translation as well as rotational, vibration, all we will include. But in this formula E we are taking like a half mv RMS square. So this is the translational kinetic energy. Understood or not? They can ask like P is equal to 2/3 E by V. E is the linear kinetic energy, E is the total kinetic energy of the gas, E is the rotational kinetic energy. So E is the here translation kinetic energy. Okay. Okay. Another way maybe like suppose they are saying, I'm saying P is equal to pressure of a gas is the 2/3 E. Pressure of a gas is the 2/3 E. What is the E represent there? Pressure of a gas P is equal to 2/3 E. What is the E represent there? Energy per linear kinetic energy, average linear kinetic energy per unit volume. Because if I'm using the P is equal to 2/3 E, so in the place of E by V, I'm writing E. It means that E is the what? Linear average linear kinetic energy per unit volume. Okay. So E by V, what we can say? Average linear kinetic energy per unit volume. Okay. So they will not ask the question on this. That directly formula they can ask. Okay. Formula question, most of the question they ask from this like RMS speed or energy or internal energy. Okay. These are the only formula we have to remember. Okay. Completed? So try to remember this directly. Okay. Now next is the average kinetic energy of gas molecule. That I said the for a gas linear kinetic energy. Now I am saying the average kinetic energy, one gas molecule, what is the average kinetic energy? I am saying the average kinetic energy, not linear, not rotational, including all. Average kinetic energy I am talking about. Okay. So P we are getting what? 1/3 mn by V into V RMS square. Okay. So here m mass of molecule, V RMS square, velocity square. Again the same thing I can do, multiply with 2, divide with 2. Okay. Yes or no? So I can say what? PV is equal to 2/3 into 1/2 m V RMS square into, this is the capital N. Okay, into capital N. What I did, just I multiplied by 2, divide by 2, no change. Small m means mass of one molecule into V RMS square into half. So half m V RMS square, this is the kinetic energy of the one molecule. Yes or no? Everybody got or not? This V I shifted here. Directly you can remember the result, but I am showing. Okay, and number of molecule I have taken here. Now from the ideal gas equation, PV is equal to what? Because this is also the pressure of ideal gas. Okay, so PV is equal to, I can say what? nRT. nRT I can say number of mole is the what? Number of molecule upon Avogadro number into R into T. That you will get 2 by 3. It is the kinetic energy of the molecule into N. So this N cancel out. R by Na, that new quantity you will learn. R by Na is called the, I am writing K suffix B. That is called the Boltzmann constant. Maybe you have heard the name. R by Na, that is called the Boltzmann constant. The value of K is what? R is the 8.314, 6.023 into 10 to the power 23. You will get 1.38 into 10 to the power minus 23. Magnitude, I will say the dimension or unit later. Everybody got? Okay. Okay. So one thing, if suppose I am asked later, I will ask dimension and unit. So R by Na I can write K. So from this you will get the Boltzmann constant Kb into T, that is equal to what? 2 by 3 into kinetic energy of the molecule. Then from this we can say kinetic energy of molecule is equal to 3 by 2 Kb into T. This directly remember last year also they asked this question. What is that average linear kinetic energy of the gas molecule? So they ask the metric match, they ask the pressure formula, they ask the average kinetic energy of the molecule. Okay, and for one more they ask, that I will discuss later. Okay, so kinetic energy of the molecule, what we got? 3 by 2 Kb into T. Remember this directly. Okay. Okay, so from that we got the one more relation. PV we can write as the NKT. PV is equal to NKB into T. Means that is another form of the ideal gas equation. If you are using the mole, so you will write the nRT. PV is equal to nRT. When you are using the N is the mole. If you are using the number of molecule, then ideal gas equation you can write PV is equal to NK into T. Yes or no? Why? Kb is the what? R by Na. N upon Na you will get the mole. So PV is equal to NKT. This is also the one form of the ideal gas equation. Okay. Okay. So we have learned the 3-4 formula. One is the pressure. P is equal to 1 by 3 m capital N by V into VRMS square. Then density and pressure relation. P is equal to 1 by 3 rho into VRMS square. VRMS, what is the VRMS? I explained that. Okay, and now we have learned the pressure and energy relation. P is equal to 2 by 3 into E by V, where E is the average linear kinetic energy of a gas. And this formula we learned for the particular molecule. Molecule average kinetic energy is what? 3 by 2 Kb into T. Okay. Understood? Okay. And one more thing that remember, like when they are asking the molecule, then they are talking about the molecule. Whether it is a diatomic molecule, diatomic gas molecule, monatomic gas molecule, if they are asking the average kinetic energy of a gas molecule, always we will write the 3 by 2 kT. In NCERT particularly that they have given, it is an important point to remember. Whether they are asking the monatomic, diatomic, internal energy of the gas will change, but if they are asking particularly for the molecule, so for the molecule, whether it is a diatomic gas molecule or monatomic gas molecule or the polyatomic gas molecule, average kinetic energy, I'm not using the linear word also, average kinetic energy of the gas molecule is always 3/2 kb into T, where K is the Boltzmann constant. Understood? So that you can write here, average kinetic energy of molecule does not depends upon nature of gas. It is same for all monoatomic, diatomic, gas. So one thing we can say, average kinetic energy of gas molecule is directly proportional to absolute temperature. Why? 3/2 K is the constant. So we can say average kinetic energy is directly proportional to absolute temperature. Okay. Completed? Okay then. Okay. So there is small question. Suppose I am asking ratio of kinetic energy of chlorine and helium molecule at temperature 27 degrees C and 127 degrees C respectively. What is the answer? Ratio of the kinetic energy of the chlorine and helium molecule at temperature 27 degrees C and 127 degrees C. So answer is the directly 3/4. Here it doesn't matter that one is the monatomic, one is the diatomic. That will not affect, only we will see the temperature factor, because I am asking for the molecule. Read the question carefully. Molecule and the gas, answer will be different. Gas I will discuss later. Okay, I am asking for the molecule, so molecule directly will say 3/2 kT. Now 3/2 K is constant, then I can say what? Kinetic energy, ratio of kinetic energy. So kinetic energy of chlorine upon kinetic energy of helium, directly will say temperature of the chlorine upon temperature of the helium. So temperature of the chlorine I have given 300 Kelvin and this I have given 400 Kelvin. So answer you will get the 3/4. Okay. Okay. So if I am asking how much temperature rise so that the kinetic energy of the chlorine molecule become double. How much temperature rise so that kinetic energy of chlorine molecule double. So kinetic energy double means you will say what? Then you can say for the chlorine particularly I am asking. Find rise in temperature. So kinetic energy of chlorine molecule become double. What is the answer? 300. Then you will say again K2 by K1, you can say what? T2 by T1. Kinetic energy become double means K2 is equal to 2K1. Then you will get what? 2K1 by K1 is equal to T2 by T1. T1 is what? 300, 27 degrees C. Then this and this cancel out. What is the T2? T2 you got 600. Now initial temperature is the 300, final temperature is the 600. How much temperature rise? 300 Kelvin. So delta theta, delta T you can say 300 Kelvin or 300 degrees C. because temperature difference will be same in both. So answer may be 300 Kelvin option may be there, or 300 degree C option may be there. Okay. Okay, so later this all formula we will use when I will discuss the internal energy of the gas. There we will discuss the more problem. Okay. Okay, so various speed of the gas molecule. This is the important, because most of the time they are asking from the RMS velocity. So here I am discussing the average speed. Day before yesterday I discussed average velocity. Suppose I am asking what is the average velocity of the gas in a container. Average velocity of a gas in a container, 0. Average velocity is 0 because they are confined in a container. So there is a no net displacement due to the random motion. Velocity, average velocity will get 0. Because velocity is the vector quantity, so molecule are moving right, some molecule are moving left, some molecule moving up, some molecule moving down. So no net displacement in a particular direction. That's why average velocity we will say 0. Okay. But now here I am discussing the average speed. So first one is the root mean square speed. That is a VRMS. So one is the RMS speed basic definition. One type of question they can ask. So what is the meaning of RMS speed? RMS speed, we know that VRMS is it is the root of mean square, That is the root 3RT by M we will use, Kirti. We will use when they are talking about the gas. Because suppose where you are sitting, air is surrounding, air is there. But we don't know which air is moving with what velocity. Which molecule is moving with what velocity. Or you have enclosed the container, you have enclosed the gas. In a container, you have the gas. I don't know what is the velocity of each molecule. Then if I know the temperature, I will say the RMS speed of the gas is the under root 3 RT by M. That is a different thing. Okay. Here suppose I am giving the 5 molecule, 4 molecule, and I am asking what is the root mean square velocity of molecules. Okay. So basic formula of the VRMS is what? Like V1 square plus V2 square Vn square by N. What is this? This is the square mean. This is the square mean. I have taken the square of all velocity, then I took the mean. Means that I have taken the summation upon total number of velocity N. So V1 square plus V2 square up to the Vn square by N is the mean square velocity. Okay. And I have to define the VRMS, so I will take the root of this. This is the root mean square velocity. This is the meaning of the root mean square velocity. Everybody got or not? And why root mean square speed? And why we define this speed? Reason is what? Molecules are moving, but due to the random motion, some velocity positive, negative. That's why average velocity we are getting negative. But when we square all velocities, so maybe velocity is negative, but after squaring, what you will get? Only positive. Understood or not? That's why we define the RMS velocity of the gas. Okay, and we assume that when they will say the average velocity of the gas molecule or gas molecule velocity, always we will take the RMS velocity. Remember that when we are saying that gas molecule is moving with the velocity or velocity of the gas is this, it means we are talking about the RMS speed. That speed, we assume that average speed basically with which all the molecules are moving. Okay. Okay, so this is the basic formula. If they are giving the V1, V2, V3 some values and they are asking what is the RMS speed, we will use this relation. Okay. Now second, for a gas, okay, derivation not required now. If it is required, then you can see here. Here you can see this PV. PV I can write as PV is equal to nRT. Okay. P and V. PV is equal to nRT, and you will say what? Number of mole it is. So number of molecule upon Avogadro number. Okay? Yes or no? I need the VRMS formula. I need VRMS formula. So PV I can write as nRT. Okay? And then from that you will get the VRMS. After solving, you will get the VRMS is equal to under root 3 RT by M. So that formula came from here. Derivation not required. So directly formula we have to remember. And this we can derive from this relation. Everybody is getting or not? Okay. So we can say what? VRMS is equal to under root of 3 RT by M. This is one formula of the root mean square velocity. When we know which gas I am taking and what is the temperature of the gas, directly I can say the RMS velocity of the molecule will be under root 3 RT by M. What is the capital M here? Molar mass. What is the unit of molar mass? What is the unit of molar mass? Gram. But we will find the velocity. Most of the cases we will find the velocity in the MKS. So we have to put the molar mass in a kg. Molecular mass in a Abhiram. Molecular mass is the AMU. Molar mass is the gram. Okay. Molecular mass is a gram. But if we are calculating the velocity, so we are calculating in a MKS. If suppose option they have given the CGS, we will first calculate in the MKS, because problem is what? R. R we have learned the two values, 0.082 atmosphere liter per mole Kelvin. Second we have learned R value is what? 8.314 joule per mole Kelvin. Joule is the SI unit. Okay. So if I will use the joule, if I am using the CGS, what is the R value you will put? So then you have to know the joule and CGS relation. 1 joule is the 10 to the power 7 erg. Okay. So that's why we will not go through the CGS. If the option are in the CGS, first we will calculate in the MKS, and meter per second easily we can convert into the centimeter per second. Understood or not? Okay. So M, unit of M is the gram, but in above formula M must be okay. So don't forget this to convert the molar mass into the gram. Like suppose they have given the oxygen molecule RMS velocity. So you will put the M is the 32 into 10 in the place of M. You will put 32 into 10 to the power minus 3. 32 gram, but we have to put in kg. So 32 into 10 to the power minus 3. R value you will put 8.314. 8.3. We will not write up to the decimal 3 places. And T value according to the temperature. Okay. Yes or no? Okay. Next, suppose they have mentioned the name of the gas like nitrogen, oxygen molecule, nitrogen molecule. No problem. We know the molar mass. We will put the value, we will get the answer. But suppose they have not given the molar, they have not mentioned the name of the gas. They have given the mass of molecule. The mass of molecule of a gas is this. What is the RMS speed? They have not mentioned the name. So molar mass we don't know, because they have not mentioned the name. So what we will do, mass of the molecule they have given. So this I can say what? VRMS I can write under root of 3. Okay. What is the R I can write? Or molar mass I can say that R into T. Molar mass I can say mass of one molecule into Avogadro number. Molar mass means mass of 1 mole. Mass of 1 mole means mass of Avogadro number of molecule. If mass of 1 molecule is M, so total mass what you will get? M into Na. I repeat again, molar mass means mass of 1 mole. 1 mole contain how many molecule? Avogadro number of molecule. So mass Molar mass you can write mass of one molecule into Avogadro number. Okay, and R by Na we know that it is a K. Then I can write the formula Vrms is equal to under root of 3K Boltzmann constant into T by small m. So if they have given the mass of molecule, then we can use the formula under root 3 Kt by m, where m is the mass of molecule. But that also you have to put in kg. So when you are using the molar mass, under root 3 RT by m. When you are using the mass of molecule, then under root 3 kb into T by m. Okay. Okay. Who will say what is the dimension of the Boltzmann constant? Because maybe the sir has said earlier, when you are learning, because in the dimension we cannot teach all the topic together, all the dimension there, because at that time you don't have the idea about all the quantities. But it is your responsibility when you are learning any new quantity, you have to find the dimension of that quantity. Because every time teacher will not say the dimension, you have to find, because it is not necessary that they will ask the dimension only what quantity you have learned in the beginning. They can ask the dimension of any quantity. What is the dimension of ml2 t minus 2 k minus 1? Very good. Atmosphere liter. A dimension is the atmosphere liter k minus 1 molecule molecule minus 1. Abhiram. What is the molecule? Molecule is the fundamental quantity. Mole is the fundamental quantity. Just you have learned the one formula, E is equal to this formula. Simplest formula. You will have to use the simplest formula to find the dimension. You have learned just now, E is equal to 3 by 2 kb into T. Yes or no? Energy, kinetic energy of the average kinetic energy of the gas molecule is the 3 by 2 kb into T. This is the easiest formula you can get the dimension. Maybe sir discuss one question based on this also. Just I use, okay. Now kb is the Boltzmann constant, 3 by 2 is the constant. So E is the energy. Energy dimension is what? ml2 t minus 2. Energy dimension ml2 t minus 2. Ashwak, this is not the time, this is the temperature. E is the ml2 t minus 2. Okay. So K what you will get? T will come down. T is the temperature. Temperature is the fundamental Kelvin. K, we write the symbol K. So ml2 T minus 2 K minus 1. ml2 T minus 2 K minus 1. Yes or no? That is the dimension of Boltzmann constant. ml2 T minus 2 K minus 1. Yes. Okay. Okay then. Kirti said right. ml2 T minus 2 K minus 1. R by Na is the joule per Kelvin. R, what is the R unit? R unit is the joule per mole Kelvin. Na is the number only. Okay. Okay. So this is the what? Now RMS formula. So we have learned the how many formula? Vrms. One formula is the basic, this under root 3 RT by m. If they have given the mass of the molecule, so under root 3 KT by m. Okay. Another maybe that is we never use in the numerical problem, but if they are asking the RMS speed can be written as. So we know that from the ideal gas equation, we have learned this relation. PM is equal to rho RT. Okay. From this I can say what? P by rho is equal to RT by M. So RT by M we can replace by P by rho. So Vrms we can write as Vrms is the under root of 3 P by rho. P you have to put in Pascal and rho you have to put in kg per meter cube. Okay. Okay. Okay then. So first, very simple problem. Find RMS speed of gas molecules if I have given the 5 velocity, if 5 molecules velocity is what is that? If this meter per second, 5 molecule velocity I given, I am asking the RMS speed of the molecules. So basic formula here directly given the 5 molecules. So VRMS I can say what? Under root of 1 square plus 2 square plus 1 square plus 3 square plus 5 square by 5. That you will get what? Under root of 5 square 25 plus 9. 34, 35 and 40. 40 by 5, 8. So root 8. Root 8 we can say 2 root 2 meter per second. Okay. First formula based question, then we will discuss more. Second, you will say find RMS speed of oxygen molecule at 27 degrees C. We have to find the RMS speed of oxygen molecule that is at 27 degrees C. Find RMS speed of oxygen molecule that they are at the 27 degrees C. (15 meter per second). Okay, I'll check. So VRMS you will get under root of 3. R you will put 8.3. R T you will put 300. Molar mass we will put what? 32 into 10 to the power minus 3. Okay. Then this 10 to the power 3 will go up. So 10 to the power 5. So in that you can take the 10 to the power 4 out of the root. So you will get 100. So 100 in under root 3 into 8, 83 into 3 by 32. Okay. I have made it 10 to the power 5. In that 10 to the power 4 and this 10 I multiply with 8.3. So I got 83. So 100 10 to the power 4 root is what? 10 to the power 2. So that you got 100 out. 3 and 3 root is what? 3 you can take out. So 300. Now under root of 83 by 32. Okay. So 32 and 83. So 32 to the 64 and then 9 and this here you will get 19. So approximately 2.6. So you got the 300 under root of 2.6. Now what is the root of 2.6? Maybe in the basic mathematics are said. Who will say what is the root of approximation? We have to take because they will not give very close answer. What is the root of 2.6? So remember that if you are getting like after the decimal one number is there. So you can write like 0.5, 1.5. So listen, 2.6 you can write as decimal 2 place. When you have to find the root of the number, root of any number, root of decimal is there. So right up to the decimal 2 place. Okay. Now it is a 2, you can read as a 260. It is a 260. So just think about any number whose square is closer to 260. So 16 square is the 256. 16 square is 256. Yes or no? So 256 means 1.6 square is the 2.56. 260 we are getting 2.56. So 16 square is the 256. It is a close to the 260. Then you can write 1.6. 1.6 square is what? 2.56. So that is a close answer. I can take what? Root of 2.6. I can take 1.6. So 3 into 1.6. So answer what you will get? 480 meter per second. Okay. Somebody is using calculator also. That's why that much of exact answer they are giving. Okay. So answer they will not give very close. That's why you have to find the exact value of the root. Okay. Completed? Okay. So formula what we have, under root 3 RT by M. For the different condition, we can say when we have to use the proportionality. Like suppose I am saying the same gas at two different temperature. Same gas at two different temperature. So same gas means molar mass is same. Okay. Then what I can say, Vrms is directly proportional to under root of T. Then we can say V2 by V1 is equal to under root of T2 by T1. Okay. When they are saying the same gas means molar mass we can put in the proportionality. Then we can say Vrms is directly proportional to under root T. So V2 by V1 is the root of T2 by T1. Okay. And different gas at different temperature. Then what we can say? Vrms directly proportional to under root T by M. Then you will get what? V2 by V1 is equal to under root of T2 by T1 into M1 by M2. So no need to remember or mug up like these things. Which quantity they are saying same in the problem, that you have to put in a proportionality. Other quantity you have to include. Okay. In any formula that you have to think. Okay. Okay. Now one question. Find percentage change in Vrms of a gas if temperature is changed by number 1 6%, number 2 temperature is double. Tell what is the answer fast. If the temperature is doubled, then what will be the percentage change in velocity? And if the temperature is changed by 6%, what is the answer? One answer is the 3%. 31.4%. 3%. Next answer. Next answer. $41.4. Good. Okay. Okay. So here, what is the difference in these two problems? Here percentage change they given is more like 6%. And second problem they are saying the temperature is doubled. Okay. So in the error I said that when the percentage change they are given very small, like up to the 10% or less than 10%, we can say what? Like we know that for the same gas V directly proportional to under root T. Then we can say what? For the small change directly I can say delta V by, for small change, then I can say delta V by V, that is equal to what? Half of delta T by T. Multiply 100 on both sides, then you will get the percentage change. So this delta T by T into 100, it is a percentage change in temperature, and that value they have given 6%. Delta V by V into 100 is a percentage change in velocity. Then I can say percentage change in V, that is equal to what? Half of 6. So then what you will get? 3%. Okay. So first answer is that directly we can say when they are giving the small change like 5%, 2%, less than 10%. So directly you can multiply with power. Power of the quantity. Like here, power of the T. How the V depends on power of the T? Power is the 1 by 2. So you will multiply with power. So 6 into 1 by 2, answer you got 3%. Okay. So for the small change like 4%, so answer is the 2%. 8%, then answer approximately we can say 4%. Okay. But second case, temperature I doubled. Temperature I doubled means if I am going through this, so double means percentage change in the 100%. Because when you are doing something double, it means how much percentage you have changed. You have percentage change is 100. Okay. But 100 is a large. Because when you doing double something means you are doing the large change. Large change I cannot directly say this relation, because from that answer you will get the change in the velocity will be 50%, but that is not a right answer. So for large I cannot use this relation. Understood? So from that, for that we will go through this V2 by V1, that I can write as under root of T2 by T1. Now temperature I doubled. So I can say what? Like 20%, 30% also they have given. So you will not go through this. You will go through this. Okay. Less, what I'm saying, less than 10% you can go through the approximation. But more than that, you have to go this procedure. V2 by V1 is the under root T2 by T1. That you can say T2 is the double. So 2T1 by T1. Now T1 and T1 cancel out root 2. So V2 by V1. I said if you remember, for the percentage change, always find ratio of the final to the initial. Subtract 1 on both sides, you will get the fractional change. Multiply by 100 on both sides, you will get the percentage change. For the large, like this type of problem, you will always find final upon initial, subtract 1 on both sides and multiply by 100. So V2 by V1 minus 1 is the under root 2 minus 1. Then this you got delta V by V1. Fractional change in the velocity you got 1.414 means minus 1, 0.414. Okay. Now percentage change, multiply by 100 on both sides. It will be 41.4%. So percentage change in the velocity will be, now approximation is giving the 50% result and this is giving the 41.4%. So large difference is there. Okay. Got? Okay. Okay. So next problem you will do. Find temperature at which Vrms of hydrogen molecule at minus 23 degrees C is double of oxygen gas. temperature of O2 gas, you can say. Find temperature of oxygen gas at which RMS speed of the hydrogen molecule at minus 23 degrees C is double of oxygen gas. So we have to find the temperature at which oxygen gas RMS speed is the half of the RMS speed of the hydrogen molecule at minus 23 degrees C. Tell what is the answer. So relation what they have given, RMS speed of hydrogen is double of RMS speed of oxygen. Okay, so hydrogen RMS speed what we can say, root 3 R. Temperature of hydrogen gas they have given minus 23. Minus 23 means when you add 273, so 273 minus 23, what you will get? 250. So 3 RT by M. For the ratio, there is no need to convert the gram into the kg, because ultimately both sides 10 to the power minus 3 will get cancelled out. When we need the exact value of the velocity, then we have to take the minus 3. Otherwise, there is a basically ratio required. So I can take here molar mass 2, that is equal to 2, and oxygen they are asking, so 3 R. Temperature of the oxygen they are asking, so suppose that is a T, upon molar mass of oxygen you will take 32. Now square on both sides, so 3R get cancelled out, squaring, then you will get 250 by 2, that is equal to what? 4 into T by 32. Now 4 8s are 32, and then here you got the 4, so T you got 1000 Kelvin. 18, how you got 18, 416, 250, 18. What are these answers? 18, 416. So if they are asking in the degree C, so just subtract the 273. Are you understood or not? Okay, everybody is getting the answer 1000 Kelvin. Okay, completed. Okay, next, find ratio of RMS speed of argon gas at 2 atmosphere pressure and 27 degrees C and 3 atmospheric pressure at 127 degrees C. Find ratio of the RMS speed of the argon gas at 2 atmospheric pressure and 27 degrees C and 3 atmospheric pressure at 127 degrees C. What is the answer? Root 3 by 2, root 3 by 4, 3 is to 2, root 3 is to 2. Okay. Good. So here pressure they have given. So pressure they have given to confuse only, because when the temperature they have given and gas they have mentioned. So basically under root 3 RT by M. Now same gas means molar mass constant, so means only temperature dependence we will see. Pressure is the different, so pressure will different, then root density will also be different. Okay. Then pressure effect we don't have to include in the velocity, because directly from the temperature effect we know under root 3 RT by M, and same gas I am using, so I can say directly proportional to under root T. So temperature they have just, pressure they have just given to confuse. Okay. So then directly we can say V2 by V1 or V1 by V2. is equal to under root of T1 by T2. So then you will get under root of 300 by 400. The people may start thinking the formula under root P by rho, not required because density data they have not given. Pressure will be different, so density will be different. Okay. But temperature they have given, so we will always see the temperature effect. So then you will get root 3 by 2. Completed? Okay. Next problem. Suppose I am saying 2 mole of gas at pressure 2p and volume 3v, and another gas of 1 mole at pressure P and volume V. Find ratio of not another gas. Find ratio of RMS speed. Tell what is the answer. 2 moles of a gas at a pressure 2p and volume 3v, and same gas 1 mole at pressure P and volume V. Then find the ratio of the RMS speed. Root 3 is to 1. Okay. Root 3 is to 1. Any other answer? Root 3 is to 1. Maybe then root 3 is to 1 is the right answer because most of you are giving the same answer. So here temperature I have not given. So because we have given the data about the pressure, mole and volume. So same gas means directly we can say what? V1 by V2. V1 by V2 is equal to under root of T1 by T2. But temperature data they have not given directly. So we have to find by the given data pressure and volume. So we can say what? T is equal to PV upon NR. Okay. From the ideal gas equation. So T1 by T2 we can write as a what? P1 V1 upon N1 into P2 V2 by N2 because R is constant. Now P1 initial pressure, that pressure I have given 2P. V1 I have given 3V, and number of mole in the second case I gave 1 upon N1. First case mole I gave 2. Final pressure P and volume V. So VP cancel out. So this 2 and this 2 cancel out. So we got what? 3. So T1 upon T2 is the 3. So V1 by V2 what you will get? Root 3 is to 1. Okay. Completed. Now one you will do at home. You have to find the order of the temperature on the Earth's surface so that hydrogen molecule will leave the Earth's surface. I repeat the problem again. Find the order of the temperature. Find the order of the temperature on the Earth's surface so that hydrogen molecule will leave the Earth's surface. It will fly off from the Earth. Find temperature of the Earth's surface or Earth so that hydrogen molecule will leave the Earth. Okay, that is your homework. You will do. So maybe escape velocity, you know that escape velocity on the Earth's surface is the 11.2 kilometer per second. That you have to use. Okay, here. So RMS speed you will equate with, find order of the temperature. Find order of the temperature at which hydrogen molecule will leave the Earth's surface, or it will escape from the Earth's surface. Gagandeep, got it? Find the order of the temperature in a Kelvin order of the temperature at which hydrogen molecule will escape the Earth's surface. So you have to equate the RMS speed with the escape speed. Escape speed is the 11.2 kilometer per second. You will solve. Okay. 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 10 to the power 4k. Maybe that order you will get. Okay then. So this is about the RMS. Now other velocities first we have to discuss. So second velocity is the most probable velocity. We'll write as a VMT. Okay. So Maxwell has drawn the graph for the molecules and he plotted the graph with the velocity and the number of molecules. So he got the graph like this. So the velocity with which some particular velocity with which the more number of molecules are moving, because here it is showing what different molecules, like this number of molecule are moving with this velocity, this number of molecule are moving with this velocity, this number of molecule are moving with this velocity. So different numbers, because some molecule, all molecules does not have different velocity. Some molecule are moving with the same velocity. So number of molecule with moving with which particular velocity, he took the on y-axis and velocity on the x-axis. So this number, this velocity, this number of molecule are moving with this velocity. So among all, corresponding to this number of molecules are maximum, and this is the velocity corresponding to that. So one particular velocity we are getting at which, for which maximum number of molecules are moving. For one particular velocity, maximum number of molecules are moving. That velocity is called most probable velocity, because actually it will come from the probability curve. Okay, but that there is no need to know. So most probable means, suppose container you have and so many that molecules are moving with a different velocity. If randomly you pick any molecule, so it is a maximum possibility is what it will move with that velocity. So that velocity is called most probable velocity. Why? Maximum number of molecules are moving with this velocity. So if you randomly pick any velocity, so it is a more chance that what you will get the same. Like suppose I am saying 1, 1, 1, 2, 3. 5 molecule, they are moving with this velocity. So if randomly you pick any molecule, what is whose velocity chance is more? You will get the 1. Okay, so 1 is what? Most probable, means maximum possibility of getting the velocity is what? 1. Which velocity you will get? 1. Understood or not the meaning of the most probable velocity? Okay, so what is the most probable velocity? It is the velocity with which maximum number of molecules move in a gas. Understood? So it is the velocity with which maximum number of molecules move in a gas. Okay, so this you will get the VMT. Okay, formula of the VMP is equal to what? Under root of 2 RT by M. But rarely they ask these things. This velocity maximum we deal with the RMS speed. Formula RT by M factor is the same in all. Only this constant will change. RMS 3. Here we are getting the 2. You can make it speed. We are dealing with the speed. That will be more better. Okay. Next is the average speed, not average velocity. So average speed, V average, that is the basically what? V is equal to, V average is the V1 plus V2 magnitude basically we are taking, because we are dealing with speed upon N. And formula what we will get? V average is equal to under root of 8 by pi RT by M. Now here also you can see RT by M factor is the same, but constant is different, 8 by pi. Okay. So average speed basically mathematical meaning is what? Sum of all the speed upon total number of molecule. And formula for the gas what we are getting? Under root of 8 by pi RT by M. Okay. Now what is the order of the velocity? Which velocity is maximum among all? Which velocity is maximum among all velocity? RMS. So order is the RAM. RAM means what? VRMS, R, then average, then VMP. So RAM. Okay. So RMS is maximum, then average, then most probable velocity. Okay. So in the graph, if you have to plot, so here VMP, here is the VRMS, then here somewhere you will get V average. Maximum is the RMS, then average, then MP. Okay, so most probable they will ask by either formula, rarely, otherwise like this type of problem, they will give the velocity of molecules are what is the most probable velocity? How you reach to the directly mean free path? Mean free path is small n. When we will use small n formula means that is the number of molecule per unit volume. Wait, mean free path will come later. What is the most probable? So VMP you will get what? 2 meter per second. Okay. Average what you will get? Average speed is equal to 1 plus 2 plus 2 plus 3 plus 2 plus 4 by 1, 2, 3, 4, 5, 6 upon 6. Then what you will get? 2, 2, 4, 5, 5, 3, 8, 8 to 10, 10 plus 4, 14, 14 by 6. That is equal to 7 by 3 meter per second. So average speed we got this, and the most probable is what? 2. Okay. Completed. So this is about the all speed. Okay. Okay. Now we have to discuss the internal energy of the gas. So I have to start, or I have to start next class? Choice is yours. Syllabus is up to the expansion of gases only. Next class. I have given the assignment for the typing. So maybe some problems you will get assignment on liquid, because liquid in our module also there's less problem has given. Okay, okay, Ashwat, no problem. Okay. So, but one thing I will try to that make the slight change in the timetable. Class time will be around 12. Okay, like 11:45 has given the schedule because I have to come from the other campus. It takes around 15 to 20 minutes to drive. Okay, so next classes, then when you'll get the timetable, I will try to mention in that. Otherwise, 12 to 1:30 we can make. Any problem? Okay, okay then. So I'm not starting the energy. One thing first, NEET like 700 plus. Any average student can also get the 650, 680. This year also we have seen so many students. Like they were not very good, but they were consistent only. And they got the 650, 600, 700 plus. Math, you have to good in all the subject. Okay. And throughout the like 2, 3 year, 4 year till the NTA has conducting the exam. So NTA is conducting. So no physics they are not giving difficult. Everybody was saying 2021 was difficult, but 2021 was difficult, but it was also not difficult. So more practice than like you are making the concept from the problems. It is better that first make your concept stronger. Okay, so read the things carefully, read each and everything, units and all, you have to be conscious. Read the question properly, because the student don't read the question, they are in the hurry and they have done the so many mistakes from the who are doing in the practice exam, they have done the same mistake in the NEET also. In the gym material, if you have, so page number 85, like kinetic theory, that whole thermal they have given together. So 85 and 86, some problems they have given on the expansion. 85 complete page and 86 like are approximately all 2-3 problem as from kinetic theory. Otherwise you can do for the expansion of gases. Gym material, page number 85 and 86. Okay, I will try to send the gym material soft copy in the online. I will ask. Okay. Okay then, bye-bye. So, but next class, remember, I will 12 to 1:30 will take. I will take. Okay. 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 Bye.